بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 1.5 and it's about inverse functions and logarithms. Well, let us start by defining a one-to-one function. A one-to-one function never takes on the same value twice, which means if I have x1 and x2, then f of x, and they are different, x1 is not equal to x2, then f of x1 would be different than f of x2. So for example here, function f is 1 to 1 because f of 4, 10, f of 3, 7. So 4, for example, here is an image for only one number, which is 2. So it is 1 to 1. But G is not 1 to 1 because 4 is the image of 3 and 2. So f of 3 equals f of 2, but or while 3 is not equal to 2. The definition, if x1 is not equal to x2, then f of x1 shouldn't be equal to f of x2. But what happened here, uh, that 3 and 2 are different, but their images are is the same, which is b, only one image. So this function is not one-to-one. What is the problem with not one-to-one functions? I cannot define the inverse. If I reverse the arrows, so from 4, I will have 2 arrows, which means it's not a function. So I cannot define the inverse function if the function is not one-to-one. How to find out from the graph that the function is one-to-one? I use what is called the horizontal line test. It would be one-to-one if no horizontal line intersects the graph more than once. So y equals to x cubed is one-to-one because each horizontal line intersects the graph once, but y equals x squared is not one-to-one because this horizontal line, for example, intersects the graph in 2 points. So this is not one-to-one. You will find that 2 and -2 have the same value, which is 4. Although 2 is different than -2, but f of 2 is equal to f of -2, so it is not one-to-one. So here, for example, if this is 2 and this is -2, they have the same image. Okay, now if the function is one-to-one, then it has an inverse. We will call the inverse like this, f to the power -1, f inverse. So this is the inverse function, okay? Now, the inverse function has the domain B and the range A, while f has the domain A and range B, because we are switching, this function, f goes from here to here. Now f inverse will go from here to here. So this is A, it is the domain of f, but it is the range of f inverse. This is the set B, it is the range of f, but it is the domain of f inverse. Now, what is the definition of f inverse? This is the definition. If the function f takes x to y, then the function f inverse takes y to x. Okay, so f take x to y, f inverse takes y to x. So f of x equals y means f inverse y equals x. That's the definition of the inverse function for any y. So the domain of f inverse would be the range of f, and the range of f inverse would be the domain of f. For example, the function f of x equals x cubed, the inverse function of this function is f inverse equals x to the power 1 over 3. How to find out? Uh, okay, we can do the following. Y, if y is x cubed, this is f of x. If we call it y, f of x is y as we know. So if y is x cubed, then what would be f inverse y? F inverse y would be f inverse x cubed. And the definition of f inverse is x to the power 1 over 3. So f inverse of x cubed, I go to the definition of f inverse of x, replace x by x cubed. So I will have x cubed to the power 1 over 3. 3 times 1 over 3 is 1. So I have x. So I proved here that y equals f of x implies that x equals f inverse of y. Here x equals f inverse of y. So they satisfy this definition. So actually f inverse of x is correct in this case. Now pay attention to this notation and this notation. This is the inverse function, and it is not equal to 1 over f over x, 1 over f of x. But this notation means 1 over f of x. It is the reciprocal, okay? 1 over f of x. So if you need 1 over f of x, you write it like this. But if we write it f to the power minus 1, this is the inverse function which has this definition, okay? Example, f is 1 to 1, f of 1 is 5. So what would be f inverse 5? F inverse 5 should be 1. Why? Because f of 1 is 5. So if f takes 1 to 5, f inverse should take 5 to 1. F takes 3 to 7. So f inverse of 7 should be 3. F takes 8 to negative 10. So f inverse of negative 8, negative 10, sorry, is 8. All right. So this is f. It takes 1 to 5. F inverse takes 5 to 1. The domain of f is A, the range is B, the domain of f inverse is B, and the range is A. So that's the definition. If f takes y to x, f inverse takes x to y. So they cancel each other because f here, for example, f takes 1 to 5, f inverse brings 5 to 1 back. So f inverse circle f of 1 would be 1 because f of 1 is 5 and f inverse of 5 is 1. So they cancel each other. So f inverse of f of x would be x. And also f of f inverse of x would be x. For example, f of f inverse of 7. Okay. Now f inverse of 7 is 3, but f of 3 is 7. So the answer would be 7. They cancel each other. So this is the composition of f and f inverse would be x. X goes into f, the input is x, the output would be f of x. For f inverse, the input is f of x, and the output would be x. So if f inverse follows f, then they cancel each other and we have x. For example, we said that f inverse is x to the power 1 over 3 for x cubed. So you can show that f inverse of f of x is equal to x. Just write f of x first. So this would be f inverse of f of x, which is x cubed. And f inverse of x cubed would be x cubed to the power 1 over 3, which is x. While here, we have f of f inverse of x, which is x to the power 1 over 3. And what is f of x to the power 1 over 3? We replace x here by x to the power 1 over 3 and raise it to the power 3. Again, they cancel each other, and the answer is x. So here we are checking also. This is another way to check that f inverse of x is correct. Now, how to find f inverse of x if the function is 1 to 1? Well, there are some steps, certain steps. For example, we have the function f of x equals x cubed. How did we find f inverse? First step, write y equals f of x. So we replace f of x by y. This is the first step. Solve the equation for x in terms of y. Then we solve this equation for x. To solve this equation for x, I will write it first. X cubed equals y. And then I raise both sides to the power 1 over 3, or taking the cube root of both sides. So x would be cube root of y. So I solved this equation for x in terms of y. Now, step 3, uh, interchange x and y. So I interchange, I write it y equals cube root of x. So x would be y and y would be x. And finally, write y as f inverse of x. So f inverse of x would be cube root of x, or x to the power 1 over 3, which we found in the previous example. Find the inverse function of this function. So again, first step is to write y instead of f of x. And then we solve this equation for x. To solve it for x, I will take 2 to the other side. And then I will take the cube root of both sides. And then I will interchange x and y. And finally, I will replace y by f inverse of x. And you can check that if circle f inverse would be x, and f inverse circle f would be also x. Now, when we interchange x and y to find the inverse function, actually we have a point AB. If we have a point AB on the graph of f, and we interchange x and y, then the point BA would be on the graph of f inverse. So this is the point AB. If you interchange x and y, you will have BA. So this point would be on the graph of f. This point would be on the graph of f inverse, which means uh, the graph of f inverse is the reflection of the graph of f about the line y equals x. So if this is the graph of f, to obtain the graph of f inverse, you reflect the graph of f about the green line y equals x. The graph of f inverse is obtained by reflecting the graph of f about the line y equals x. So for example, sketch the graphs of f and its inverse function using the same coordinate axis. He is asking about the graphs of f and f inverse. So we don't have to find f inverse. He needs the graph of f inverse. So let us start by graphing this function. Well, to graph this function, the standard function is the square root function. And the square root function has this graph. Now, do we have transformations? Yes, we have a horizontal shift here, horizontal shift. If I graph square root of x minus 1, so that's the horizontal shift. I prefer to write this as negative x minus 1. So forget about this minus. I have x minus 1. So there I should take the graph 1 unit to the right. So if you take the graph 1 unit to the right, it would be like this. So this is the graph of this function. Now, this is h. Remember the order of transformation is h, s, r, v, where h is the horizontal shift. S stretching or shrinking, we don't have here. R reflection. We have a reflection because this is negative x. When you multiply x by negative, you reflect the graph about the y-axis. This is the y-axis. So now I can graph the function negative x minus 1 by graphing, by reflecting this one about the line y-axis. So this would be the graph of this function. Okay. Let me call this just y because there is only one f of x. So this is y and this is y. Okay. And this is the graph of f of x. Now I also want to graph f inverse of x. Well, I have this point. What are the coordinates of this point? Negative 1 and 0. Negative 1 and 0 belongs to the graph of f. So 0 and negative 1, which is this point, will belong to the graph of f inverse. If you find if x is negative 2 here, if you replace x by negative 2, negative 2 is 2, 2 minus 1 is 1, so actually this is 1. So this point has coordinates negative 2 and 1. If you interchange x and y, I will have 1 and negative 2. So this point. So you can sketch the graph like this. This would be the graph of f inverse. Both lines are symmetric about, both graphs, sorry, are symmetric about this line, which is y equals x. So actually we reflected the graph of f about the line y equals x to graph f inverse. So we were able to graph f inverse without having its definition from the fact that if AB belongs to the graph of f, then BA belongs to the graph of f inverse. Now we have the exponential function. This is the exponential function. We know the graph of the exponential function, and from the graph we see that it's 1 to 1. The exponential function is 1 to 1. It passes the horizontal line test. So it has an inverse. To find its inverse, let us replace f of x by y. Now to solve this equation for y, we introduce, to solve this equation for x, sorry, we introduce the logarithmic function. So we write this as x equals log y to the base b. And then we replace x and y, interchange x and y. And finally, we write y f inverse of x. So f inverse of x is log x to the base b. So if f of x is b to the power x, then f inverse of x is log x to the base b, and thanks to this definition. If x equals by, then y equals log x to the base b. Or you can say from here, you can say that how to obtain log x to the base b? Well, log x to the base b is y, and y is the power in which you raise the base b to it to give you x. So for example, to find this log, you think of 10 to which power equals 0.001. Then you realize that 10 to the power negative 3 equals this number. So this log would be negative 3. So this what this definition says. Now, since now we have f and f inverse, This is f and this is f inverse. If you find their composition, you will find something like this. Log bx to the base b. It should be equal to x because f circle f inverse is x. And f inverse circle f is x. So also b to the power log x to the base b is x. So the logarithmic and the exponential cancel each other and you get x. Here also the logarithmic and the base, the exponential, cancel each other and you get x. So these are two properties. Now, if you remember, the domain of the exponential function is all real numbers. So the range of the logarithmic function, because it's the inverse, would be all real numbers. The red one is the graph of the logarithmic. The range is all real numbers. While the range of the exponential is from 0 to infinity, so the domain of the logarithmic from 0 to infinity. Notice that the graph of log and is how to obtain the graph of log x to the base b. You reflect the graph of y equals b to the power x about the line y equals x because they are inverses of each other. For example, this point is 0, 1. So we have 1, 0 here. Okay. These are some examples of some bases. Okay. If base 2, the green, base 3, it goes closer to the axis. Okay. From here and also to the y-axis. So log 10, for example, closer to the x-axis and closer to the y-axis. All of them pass by the point 1, 0, log x, then log 1 for any base would be 0. Okay. These are some, of course, here uh, when b is greater than 1. If b is less than 1 and greater than 0, the graph of the logarithmic would be like this. And the graph of the exponential would be like this. And both graphs are, or if you if you uh, if you want, you can find the graph of f inverse, the logarithmic function, which is uh, this one. This is the graph of log x to the base b here. And this is the graph of b to the power x, but b is less than 1. So you can see that the graph of log also in this case is the reflection of the graph of b to the power x about the line y equals x, the green one. These are laws of logarithms. Log product x times y changes to, this is one log, changes to the sum of two logs. Log one term, which is x over y, changes to two logs, log x minus log y. This is division. So we change division into subtraction. But this is one log, and here we have two logs. If we have r here as a power of x, we can take r out. So it would be r times log x to the base b. So for example, log 3x would be equal to log 3 plus log x, while log x over 2 would be log x minus log 2, while log 9, for example, would be equal to log 3 square, because 9 is 3 square, would be equal to 2 log 3, because we can take the power outside. Okay, these are some examples. Use the laws of logarithms to evaluate. I have two logs and a minus sign, so this changes to one log. The base is 2 and 80 should be divided by 5. So I have one log here. 80 over 5 is 1, 6, 16. So that's the answer. If you think of this, if I ask you, what is this? So you think of 2 to which power equals 16? Well, 2 to the power 4 is 16, so this would be 4. If you use your calculator, you will find that this log is 4. If the base is e, if the base in the logarithmic function is e, then we call it the natural logarithm and we give it a special name, lnx. So what is lnx? It is log x to the base e. So if the base is e, we just write lnx. So y would be equal to lnx if x is e to the power y, because the base is e. And the composition between ln and e, they cancel each other. Ln ex would be x and e ln x would be x. Now, if f of x is ex, then f inverse of x is ln x, the logarithmic function, ln x, okay, with base e. These two are inverses of each other. The graph of ex is like this, and the graph of ln x is like this. And they are, the graph of ln is the reflection of the graph of ex about this line, y equals x. So in general, if x is 1, then e would be 1. And x to the power r, we can write it e, we can write it e to the power ln, because look here, x is e ln x. So xr would be written e ln xr. And now we can take r outside using the property, this one, the last property here. So we can write x to the power r as er ln x if we need. Find x if ln x is 5. Well, using this property, if ln x is 5, this means that x is e to the power 5. X is e to the power 5 immediately. If you like, you can solve it in another way. You can raise this equation to the base e. So ln x5, you put e here and e here, okay? So now we know that e and ln cancels each other from here. So I will have that x is e to the power 5. Same solution. How to solve this equation? Well, I have to bring x down so I can apply ln to both sides. Now ln cancels e. So 5 minus 3x would be equals to ln 10. I need to solve it for x. So I'll take 5 to the other side. So negative 3x would be equal to negative 5 plus ln 10. And now x would be negative 5 plus ln 10 over negative 3. And that's the exact answer of x. You can approximate by the calculator. Use the laws of logarithms to expand. These are the laws of logarithms. And we expand when we go to this direction. We have one log, we expand we get 2 logs. Okay, so I have division, so I will write it ln x square times x square root of x square plus 2 minus ln 3x plus 1 using the second law, changing division into subtraction. Here I have multiplication, so I will change it to addition. So I will have ln x square plus ln x square plus 2 under the square root or to the power half minus ln 3x plus 1. Finally, I use law 3 to take the powers out. So I will have 2 ln x plus half ln x square plus 2 minus ln 3x plus 1. And this is expanding. Express as a single logarithm or condense. So I have 2 lens here and I needed single logarithm. So I go in the other direction. Here expanding, this direction will be condensing. If you have 2 log, write it single logarithm. So what do we have here? We have ln a plus. Okay, but I have this half. This half is a problem. So what should I do first? I should take it up using law 3. So I can write it ln b to the power half. Now I have plus, so I can change it to single logarithm and I multiply a times b to the power half, or b to the power half, I can write it square root of b. So that would be the answer. Change of base formula. If the base is b and you want to change it to a, okay, you want to change it to a, the formula would be log x to the base b. The new base is a, so write log over log and put the new base and then put x here and b here. This is the general formula. If you want to change it to the base e, so log e would be ln. So you will have ln x over ln b. Also, if the base is 10, we write it. If the base is 10, we just write it log x without a base. Okay. If we don't write the base, it means it is 10. So if we change to the base 10, we can write it log x to the base 10 over log b to the base 10. So log xb would be ln x over ln b, or log x over log b, or this one. We mentioned this. This is the graph of e to the power x, and this is the graph of ln x. They are inverses of each other. And that's why they cancel each other. Ln ex is x and ln x is x. Sketch the graph of this function. The standard function here is y equals ln x. So we start by graphing this function. This is the graph of ln x. Notice that there is a vertical asymptote. This line is a vertical asymptote. Okay, I have a horizontal shifting. So I will sketch the graph of ln x minus 2. Take this graph 2 units to the right. When you take it 2 units to the right, this line, which is x equals 0, which is the vertical asymptote, will move 2 units to the right. So it would be here. And this point, which is 1, you move it 2 units to the right, it would be 3. And this would be the graph of ln x minus 2. If you take 1 unit down, you graph ln x minus 2 minus 1. Taking this graph 1 unit down will not change the vertical asymptote, but it will change this point. Instead of 3, you take it down 1 unit, so it would be here, and the graph would be like this. Okay, So this is the graph of this function. What is the domain? It's from 2 to infinity, and the range is from negative infinity to infinity. The domain of any logarithmic function, this one should be positive. What is inside the len should be always positive. So x should be greater than 2. And the domain is from 2 to infinity, which also we see from the graph. Let us define the inverse trigonometric functions. Well, the trigonometric functions are not one-to-one. In general, they are not one-to-one. For example, this is the graph of sine. It doesn't pass the horizontal line test. So it's not one-to-one. So we will not be able to define an inverse of sine x unless we restrict sine x on a specific domain. So if we choose from negative pi over 2 to pi over 2 from here to here, this would be the graph of sine x in this domain from negative pi over 2 to pi over 2, and now it passes the horizontal line test. So I can define the inverse function. How? If sine y equals x, then sine inverse x would be y. So this definition will work only if the domain of sine, which is in this case y, because y is the input of sine. So the input of sine should be from negative pi over 2 to pi over 2. To remember this, remember if you graph an angle, you go negative pi over 2 in this direction and pi over 2 in this direction. So this is the domain of sine from negative pi over 2 to pi over 2. First quadrant and fourth quadrant are there. Notice that x here is in the range of sine, the output of sine. The output of sine should be always from negative 1 to 1. So x should be between negative 1 and 1. All right. While y is between negative pi over 2 and pi over 2. Notice that sine inverse does not equal to 1 over sine. It is the inverse function. So if you want to write 1 over sine, you write it like this. This is equal to 1 over sine. But if you write the inverse here, so it is the inverse function, which is this function. Evaluate sine inverse half. Use the calculator to find sine inverse half. It will give you the answer. Okay. Sine inverse half is just pi over 6. So it is pi over 6. Why? Because sine pi over 6 is half and pi over 6 is between negative pi over 2 and pi over 2. All right. So sine inverse half equals pi over 6 because sine pi over 6 is half. And pi over 6 is in the domain of sine, which is from negative pi over 2 to pi over 2. Now, how to find tan sine inverse? By the way, arc sine means sine inverse. So whenever we write arc sine, we mean sine inverse, okay? Or arc cosine or arc tan. To find this, let us call y equals arc sine or sine inverse 1 over 3. Of course, you can use the calculator, but if you replace x by 1 over 3, if you replace 1 over 3 by x, the calculator will not help. So you need to understand this method. Now this is if and only if what sine y is 1 over 3. This is the definition. Y is sine inverse 1 over 3 if sine y is 1 over 3. Good. Now what do we know about y? It is in the domain of sine. And we said that the domain of sine is from here to here. So this y should be either in the first quadrant or in the fourth quadrant. But the sign of this y is positive. Sign here is negative. Sign here is positive. So the graph of y is an angle in the first quadrant. Sine y is 1 over 3. If you remember, sine is opposite over hypotenuse. Remember, so, ka, toi. Okay. So sine is opposite over hypotenuse. So sine of y is the opposite side, which is this one, 1. And the hypotenuse, which is opposite to 90, is 3. How to find this side? This side is square root of 9 minus 1, which is 8. So it's 2 square root of 2 from the Pythagorean theorem. So what would be tan sine inverse 1 over 3? Well, sine inverse 1 over 3 is y. So it would be tan y. This is y. What is tan y? Tan is opposite over adjacent. This is the adjacent. So it's 1 over 2 square root of 2. That's tan y. Of course, you can rationalize the denominator if you like. So that's the answer. Tan sine inverse would be this one. If you put it in the calculator will give you this answer. We will multiply by 2 by square root of 2 over square root of 2, and we will have square root of 2, and here 2 times 2, 4. So it would be square root of 2 over 4. So sine inverse will cancel sine only if x is in the domain of sine, which we know from negative pi over 2 to pi over 2. Otherwise, it will not be equal to x. Okay, so if you choose an angle, for example, sine inverse sine of 5, let us say 7 pi over 6. Okay, 7 pi over 6 is greater than pi. So it's not in this interval. So this will not be equal to 7 pi over 6. Okay, you have to give me x between negative pi over 2 and pi over 2. While sine inverse x, notice that x is in the domain of sine inverse. So it should be in the range of sine. Range of sine is from negative 1 to 1. So sine inverse x equals x only if x is between negative 1 and 1. Sine inverse of 2, for example, is not defined. Is not defined. Okay. This would be the graph of sine inverse. The domain is the range of sine, which is from negative 1 to 1, and the domain of sine, which is from negative pi over 2 to pi over 2. The inverse cosine function would be defined similarly, but the domain here is different, because if we choose from negative pi over 2 to pi over 2, cosine will not be 1 to 1. You know the graph of cosine, at 0 it is 1, and it goes like this. So from negative pi over 2 to pi over 2, it doesn't pass the horizontal line test. So this interval is not good. So we choose from 0 to pi. It would have this curve, and it would be 1 to 1. So remember, for cosine, we choose from 0 to pi. From 0 to pi means this is the angle 0 and this is the angle pi. So we are from here to here. We work this time with quadrant 1 and quadrant 2. Cosine inverse would be equal to cosine x if x is in the domain of cosine, which is from 0 to pi. Here x in the range of cosine, which is from negative 1 to 1. They cancel each other only under these conditions. Remember, arc cosine is cosine inverse. This is the graph of cosine inverse. Domain from -1 to 1, which is the range of cosine. Range from 0 to pi, which is the domain of cosine. Tan inverse or arctan, this is the definition. And for tan, if we choose from -pi/2 to pi/2, similar to sine, it will work. But the only difference, tan is not defined at pi/2 or -pi/2 because it has a vertical asymptote. Because cosine is 0, cosine pi/2 is 0, and cosine -pi/2 is 0. So the only difference between sine and tan, there is no equality here. So this is the definition of tan inverse, and this is the definition of tan. This is the graph of tan between -pi/2 to pi/2, and this would be the graph of tan inverse. The domain, notice that the domain here from -pi/2 to pi/2, so it would be the range, and the range of tan, or real numbers, it would be the domain, which is the domain of tan inverse would be all real numbers. Notice that this line, y equals pi/2, is a horizontal asymptote, and y equals -pi/2 is a horizontal asymptote. And we understand from this graph that tan inverse of x is always between -pi/2 and pi/2. So it will never be less than this or greater than that. Let us solve this question. Simplify this expression. You immediately call this y. So I take tan inverse x and call it y. And then I use the definition of tan inverse, which says tan y would be equal to x. Tan y would be equal to x. So now I'm talking about tan inverse. Tan inverse is similar to tan. So from -pi/2 to pi/2. So it could be here or here. Tan y is x. X, he didn't say in the question anything about it. So it could be positive or it could be negative. If x is positive, then tan is positive, and the graph of y would be here. If x is negative, then tan would be negative, and the graph would be here. Okay? It doesn't really matter. At the end, we will have the same solution. Now, if we graph in the first rectangle, in the first quadrant, what do we know about y? We know that tan y is x. So what is tan? It is opposite over opposite over adjacent. So x over 1. So opposite is x and adjacent is 1. And x in this case is positive. If x is negative, it would be here, and this would be also 1. So no difference actually. But here x is positive and here x is negative. Now how can we find the hypotenuse? The length of the hypotenuse would be from the Pythagorean theorem, x squared plus 1 under the square root. So what do we need to find? Cosine tan inverse, which means cosine y. This is y. What is the cosine of y? So k, adjacent over hypotenuse. So the answer is 1 over square root of x squared plus 1. This was the last exercise. I hope you enjoyed the lesson, although it's somehow long. Thank you very much.